You're welcome in your maths, and I got a new problem. Today we are going to prove this, this and this. Now let's start with the first one. So now let's start deriving this. So this is the root form of quadratic equation, and that we have to derive as well. We know that when we solve quadratic equation, we get two roots, and the roots is basically the solution of the equation. And let's say x is equal to alpha and the root is x is equal to beta. So we can say x minus alpha and x minus beta is the factor of the quadratic equation. Let's take an example to understand it. So let's take a quadratic equation, that is x square plus 3x plus 2, and when you solve this quadratic equation, you get x plus 1 into x plus 2 and is equal to 0 as well. And from here you can get the two roots of the equation, that is x equal to minus 1 and x equals to minus 2, and that's also here x equals to alpha and beta, the two roots of the quadratic equation, and here x minus alpha and x minus beta, the factors of that quadratic equation. And when you multiply these two factors together, you get the quadratic expression. So let's multiply x minus alpha into x minus beta. So it's x square minus beta x minus alpha x plus alpha into beta is equals to 0. And when you take common, you get x square minus alpha plus beta x plus alpha into beta is equals to 0. But here you can see that the coefficient of x square is 1, but it cannot be possible always, as so we multiply k with that. So kx square minus k alpha plus beta x plus k alpha into beta is equals to 0. So this is the actual root form of quadratic equation, and that we have to prove as well. Now let's prove this and this one. So why are you waiting for? Let's start. So see, first of all, what we need, alpha plus beta. So first of all, compare the standard form of quadratic equation, ax square plus bx plus c is equals to 0. So this is the root form of quadratic equation, and this is the standard form of quadratic equation. Now compare both equations as both are same. So a is x here and b is minus k alpha plus beta here, as plus is outside, so this is actual b, and c is k alpha into beta. Now I need alpha plus beta. From here minus k alpha plus beta, how can I get alpha plus beta? Only by removing minus k. Okay, so this expression is what? B. Okay, so when I divide b with a, it means we are basically dividing LHS with k, and k cancel out, but it's minus of alpha plus beta. So when I give minus to b, so it's minus minus plus now, so we get alpha plus beta. So yeah, alpha plus beta is equal to minus b by a, and we have proved it. Now we have to find alpha into beta also. So c is equals to k alpha into beta. Now c by a is what? K alpha beta by k. So k cancel out, and c by a is equals to alpha into beta, and that's proved. Hopefully you get it. So don't forget to like and subscribe.